Ladies and gentlemen, good morning, good afternoon, and good evening. My name is Stefano Polidori from the ITU, and I'm pleased to welcome you to the fourth day of the Symposium on the Future Networked Car 2022. This is the last session this year, and we'll complete our program by focusing on wireless communications applied to vehicle safety, services, and transport management. Many thanks to Chang'an Automobile, who kindly sponsored our symposium this year. I wish to remind you that this webinar is being recorded and our webpage already includes the full recording of the previous sessions. So if you missed any of them, you might watch them offline. Two chat boxes are available. Please use the Q&A box to submit your questions at any time. I would like now to call on Mr. Russ Schill to moderate our session today. Russ has been involved in communication standards for over 40 years. In ITU, he is the chairman of the Collaboration on ITS Standards platform, which normally meet back-to-back with the symposium. And in fact, it had a meeting last Friday. Russ is also the ITU representative at the UNECE and contributes to the organization of this joint symposium on the Future Networked Car. I'm very pleased to welcome Mr. Russ Schill at this year's symposium. Russ, the floor is yours.
Thank you, Stefano. It's a very pleasure to be here as the last day of what I think has been a very, very good symposium with lots of good information and interest. To start, on behalf of my three leaders of the sessions, I would like to thank Stefano and the ITU staff that has done a fantastic job in putting this symposium together, organizing everything that could not have been done without their tremendous work day and night. So you really have my appreciation. So as Stefano mentioned, ITU and one of its activities is the collaboration of ITS communication standards. It is an effort to bring together the worldwide organizations related to ITS that are doing different kinds of standards. The meeting last Friday had about 20 different standards organizations making presentations. Please see the link that's in the chat, how to find it. The material for the whole coordination effort is there. And if you're interested, also in the chat is the email address to be able to ask for being added to the mailing list so that you can get the information. I think many of you will find it interesting. Also, as you saw in session one and as Stefano said, we are in ITU working very closely with UNECE for the World Forum for Harmonization of Vehicle Regulations, WP29. The key part of that that's related to today is the working party for autonomous, automated, and connected vehicles. The link to that website is also in the chat. It is where a massive amount of work that is being done in current regulations that have been put out, such as the automated lane keeping system, the cybersecurity regulation, the software update for the air regulation, and others. But more important as well is all the information about the working groups that are developing the new standards, and all their documents are posted. And if you go to that website in the chat, you will see there are about 10 different working groups, and if you link to them, you will get each of their different meetings and all of their documents. So those are available, and any of you who would be interested as being experts, you can contact me, our Francois Gichard, who is the staff member organizing to help. There's a really major effort. Now, this session will be organized similarly to the previous sessions. We will have a set of presentations, opening from keynote and then from 4 panelists. I will then have a discussion with our keynote speaker about ideas. We will move through the 4 panelists. The aim is to finish that by 14:30 Geneva time. We'll have a 10-minute break, and then we will come back at 14:40 for an active discussion of the 4 panelists on the questions from you as the audience. So please, for anything that you're interested to hear about or find out about, please put your questions in the Q&A part, and they will be considered. So our first speaker is Per Bemming, who is the Ericsson Vice President and Head of Standards and Industry Initiatives. Mr. Bemming provides the Ericsson technology leadership and standardization and industry initiatives, including open source. In previous roles, Mr. Bemming was responsible for the 5G program targeting 5G RAN products and demos, in addition to driving the architecture at business area networks. Before that, Mr. Bemming was the director of RBS Systems and held a role of expert in the radio access architecture at Ericsson Research. Mr. Bemming has been the head of the delegation to 3GPP. Very interested to me, he is engaged as a board member of the IOWN Global Forum, as well as an executive board member of the HAPS Alliance. Mr. Bemming holds the MS in Applied Physics and Electrical Engineering. Please, Mr. Bemming, go forward with your presentation.
Thank you, Russell. Imagine the transport industry of tomorrow that will use green energy, access to data enabling a sustainable, safe, and economical conditions across the world. To enable that, the digital transformation is the key, and wireless, and in particular the 5G system, is fundamental for that transformation, as it is for any other industry. Therefore, 5G infrastructure is as critical as any other infrastructure, such as water, energy, roads, and beyond. My name is Per Bemming. I'm Head of Standards and Industry Initiatives at Ericsson. I'm very happy to have this keynote in front of you today. Cellular networks, the backbone of digital transformation, has evolved from 2G to 3G to 4G, and now increasingly towards 5G. Complemented by the short-range technologies that is used for the automotive industry and transportation industries, the capabilities of the 5G innovation platform comes with increased bandwidth, lower latency, and higher resilience. That has enabled 5G to become the innovation platform of the future and of today for the operators, consumers, and enterprise alike. The operators have now launched 5G across the world. Over 200 commercial 5G launches has been announced, and more to come. The 5G subscription has been a faster uptake than that of 4G that followed its launch in 2009. That reached 1 million subscriptions 2 years sooner than 4G did. The key factors includes the timely availability of devices from several vendors, with price falling faster than for 4G, as well as China's early engagements and the rest of the world. By the end of 2027, we forecast 4.4 billion 5G subscriptions globally, accounting for 49% of all mobile subscriptions. 5G will then become the dominant mobile access technology by subscriptions in 2027. And one reason for this fantastic uptake is that the 5G systems are so easy to deploy in parallel to the 4G systems that is existing today and dominating. And that's because we have introduced a feature that enables the 4G and 5G to share the same spectrum carrier. And that enables the operators to use their existing 4G footprint systems. And that enables operators to seamlessly evolve from 4G to 5G without having to sacrifice carriers' scarce spectrum resources or shutting down services for legacy systems. So what can the 5G system provide to the transport sector? Of course, the transport sector has different service needs for people and goods in urban and rural areas and across borders. And there are different stakeholders that needs to be part of this journey. The transport service providers, like the logistics and public transport providers, the transport hub operators, like the ports, stations and commuter hubs, vehicle suppliers, of course, the transport infrastructure operator, the road, the rail and waterways operations. And of course, the governments needs to be part of this overall journey. And we have the complementing technologies that we have talked about, the short range and the wide range. And all of these stakeholders are going through a transformation leading up to a data-driven operation. And that transformation will lead to an increase for as much data as possible to the right receiver at the right time in order to define the most optimal and safe usage of transport resources. And that will lead to an energy efficient, safe and economical benefits for us in the communities. However, this data, that has to be trusted, be secured and accurate and understood. And of course, we have to have the willingness to and readiness to share this data between these different stakeholders. Otherwise, this journey will not be possible. Obviously, then the connectivity to access this data based on the analysis of the data will therefore be critical enabler for a safe, sustainable and efficient transport system. In this context of this communication technology, we have seen a long debate around short-range, wide-range communications technologies in the past. And we consider now both of these options as complementary tools to this transformation. And with C-V2X defined by 3GPP, we have both short and wide-range options available in the same standard, promising a global scale solution. Let's see this illustrated in a video provided by the 5G AA.
Cellular Vehicle to Everything, or C-V2X, allows vehicles to communicate with each other and everything around them. C-V2X is based on the same radio technologies used for mobile networks around the world. It's defined by 3GPP, the global standardization organization for all mobile networks. Every year or so, new 3GPP releases gradually improve the standards. They have seamlessly evolved, leading up to 5G. Tens of millions of vehicles are already connected today. They exchange valuable data on road safety and traffic efficiency via cellular mobile networks. To support growing automotive connectivity needs, Release 14 introduced LTE V2X in 2017, which integrates both direct and mobile network-based vehicular communications using the same radio. Advanced features enabling more advanced services such as cooperative maneuvers or sensor sharing will require the complementary direct communication and 5G V2X network and direct communication capabilities also defined in 3GPP. By 2022, worldwide deployment of basic safety services, including LTE V2X direct communications, will complement traffic information and local hazard warnings already widely installed today. The 5GAA roadmap predicts that automated vehicles will start getting the full-scale benefits of 5G as of 2026. Newer 5G V2X connected vehicles will continue to support LTE V2X for basic safety services, ensuring that 4G-based vehicles with LTE V2X are still included in road safety solutions when 5G comes. How will this work? Simple, really. In the same way that 3GPP standards ensure that you can still call your friends with your new 5G smartphone, even if they use an old-school flip phone. 5G V2X radios will seamlessly embed both LTE V2X and 5G, which is crucial to keep an inclusive connected car ecosystem. This is the advantage of being part of the same but evolving technology family. See V2X.
So, nowhere is the potential of cellular technology greater than within the transport sector and its mobility services for people and goods. Successful delivery of sustainable, safe and efficient mobility services has a critical dependency on access to trusted and real-time data from connected transport devices on a global scale. With the characteristics like improved latency and high capacity, the 5G network and its collaborations with short-range and wide-range services will enable a wide range of use cases for connected vehicles, such as traffic safety, autonomous or remote-operated trucks and buses, automated guided vehicles, and robotaxis. 5G technology provides a worldwide harmonized innovation platform to accelerate safe and more sustainable solutions. In order to do that, coverage is needed everywhere. The transportation sector can build upon existing road and telecommunication infrastructure that is already in place, leverage ongoing modernization and digitalization efforts in the industry. However, today's cellular networks are primarily built to meet the needs of consumers and related business models. So, for example, if you look at the car industry that have heavily invested in building the electrical vehicles, and now we realize that we really have to have the public charging infrastructure in place as well in order to drive everywhere with the electrical vehicles. So in a similar way, the consumer finance communication infrastructure is not sufficient to cater to enhanced infrastructure requirements for the transportation sector, as it's not clear that coverage will be built out everywhere so that a vehicle can be safely driven wherever it has to go. And therefore, the government should actively support this rapid expansion of digital infrastructure to geographical areas where consumer-driven market forces fail. For instance, we cannot self-drive cars if they cannot drive everywhere. So let's have a look at this scenario in another video.
Every journey we make is changing because the vehicles we make them in are changing. Because our car isn't just a car. Not anymore. It's our smartphone and sound system. It's our map, traffic report, weather vane, and personal assistant. It makes sure we're always on the grid wherever we go. It can tell us what it needs before it needs it, although sometimes it doesn't even have to. It's a software-defined, network-aware, always-connected hive of data, constantly communicating through the cloud with everything around it. Creating this always-connected car requires an always-connected mindset.
A prerequisite for realizing the potential of automated and electrified mobility services and achieving the goals of fossil-free, safe and efficient transportation is that the three societal and enabling infrastructures, the energy, the physical and the digital infrastructure, have the capacity to meet the future needs for mobility of individuals, companies and society. Today, these three types of infrastructures have completely different value chains, business models and regulatory frameworks for delivering their respective main services. Only an aligned approach will enable players in the transport system to achieve their ambitious goals in sustainability, safety and efficiency. Secondly, the transport sector is truly global, even if it's deployed based on local conditions, and it's served by global players in vehicle manufacturing and in mobility service provisioning for people and goods. For economy of scale and momentum of local innovations, enabling technologies should be based on global standards such as 3GPP for mobile networks. At the same time, it's important that any regulatory or policy initiatives remain technology neutral. Otherwise, it will be a stoppage or hindering of the technology evolutions and rapid service innovations going forward. To conclude, digital transformation is happening everywhere. Digital infrastructure on which this plethora of use cases rely on uninterrupted coverage and sufficient capacity. For the transport sector, it's imperative that the digital infrastructure is complemented with the energy, physical infrastructures in order to realize fossil-free and safe transportation. To finance these kind of infrastructure extensions, investments are needed that go beyond the consumer finance share of the infrastructure. The future transport sector of tomorrow is possible if we all collaborate and work together. Thank you, and back to you, Russell.
Thank you, Per. A really great presentation laying out how 5G is truly going to be helpful in the future. I really look forward to having 5G rolling out as you went. But let me ask you some questions. The technology itself is great, but in vehicles, if you look over the next, say, 6 or 8 years, how are vehicle manufacturers going to be making use of 5G to improve their capability of delivering to their vehicle purchasers and drivers?
Thank you, Russell. I think that is a great question, and I think just by ensuring that there is connectivity into the car, it enables a lot of interesting use cases for the manufacturer by themselves. Of course, it's a lot of sensors, it's a lot of equipment in the car that they can get instant communication back to sort of the headquarters to understand how the car is used and whether you can do predictive maintenance and all that. And I think that is one driving force for putting connectivity into the car for the manufacturer. Then, of course, the manufacturer in itself can also get another kind of channel to their consumer, the drivers or the owners of the car, through this connectivity, presenting and get a more instant and direct connection to the drivers and those that are in the car. Then obviously the passengers, and maybe if it's a self-driving car, they can use the same connectivity for which we call in another slice. Then maybe they pay for it themselves, as what they normally do when they have their smartphones, like browsing internet or watching a movie or playing games and all that in the back seat of the car or in the front seat or wherever they sit. Or if it's a bus, they could be doing that. And then, of course, it could be provided by, if it's a bus, it could be screens that is provided in the bus and all that possibilities. Then, obviously, having connectivity, as illustrated in the movies here, one can see that road authorities or road operators can also get interesting information based on the conditions on the road, are the potholes in the road or whatever, how is the condition, how does the vehicles react on that, to get that. And that might be so that they are willing to pay for that information from all the cars that is driving on the roads to get better understanding on that. And at the same time also be able to push out information about roadblocks or roadworks or even safety hazards that might occur there. Similar as government, depending on country, may operate that kind of operations to push out safety information. And then, of course, on top of everything, then there is this road fleet operators that want to see and coordinate a lot of cars and vehicles, where they are, what to go, what is the fastest route, best route, and are there anybody to pick up what goods and all that. That also then would minimize the distance that needs to be traveled, and therefore the energy that needs to be consumed, and therefore we get a better and greener society. So I think it's a lot of different opportunities here, and in the end, I think that it could be seen more like the kind of the airbags of the car. It's something that you need to have. You have to have this fun in the car because everybody requires that for various different reasons. Yourself as a car manufacturer requires for your own operations. Your passengers require that because, or the drivers or the owners of the car require it because they want to have entertainment and whatnot in the cars while doing it. And then authorities and other players would also like to have these opportunities to have that connectivity, to get the access to the data that is available through this car.
The cost for the vehicle manufacturer is has to put in the equipment in the car and hope that he get that in the price of the car covers the equipment. He then has to look at coverage, and does he have to provide the service and pay for that, or can he provide have the consumer pay for the service? What do you think is going to happen as far as who pays for the service for the connectivity?
So what we think is that we have a concept we call network slices. To the same device, there will be different slices, and the interesting easy example is three different types of slices paid by three different actors. One slice is for the car manufacturer to get the car data that the car manufacturer is interested in for the engine status and all these censorships that they have. That's one slice that I think the car manufacturer will pay for because it's related to their opportunities and so on. Then I think that the consumer, the one sitting in the car, can pay for the slice for the the movies, the games, or the internet connections in general. And then there could be another third slice that the government pays for, that is more of this information about safety things. And of course, there's a fourth player in this, which is the operator of the network that provides the connectivity to the car. That is also here in the whole mix.
Yeah, you mentioned the sharing or SIM splicing. That's a technology that the car industry has talked about for a long time. When is that actually going to be in the car where you can actually have the connectivity, SIM card, billing split between different parties?
I mean, the technology is available. There is first the same technology will also be used in the normal kind of smartphone applications. So that it could be like, for instance, myself have a company car, company phone that for company connectivity, my company pays for it. But when I use it for my private leisure, I pay for that piece. That is possible. It's a bit different in different operators around the world when they will launch this feature and how they can do it. And it is also to some extent related to legislation, since one have to understand that enabling this might also mean that you may want to have different types of priority between these different flows. For instance, the the safety or the emergency alerts should have a higher priority than, for instance, the game or the internet browsing things. And potentially that could even have higher than priority than maybe the in the background uploading of data from the car. But then regulation needs to allow that kind of priority differentiation of this connectivity. And that is something that regulation needs to ensure that works.
Yeah, and that's one of the issues that the vehicle manufacturers face, is that the rules are different among different companies with different carriers. And we hope that some of these things will be worked out as we go forward in the future. Let me ask another question. You mentioned ubiquitous coverage. If I take far northern Sweden, when is there going to be ubiquitous coverage provided across all of northern Sweden?
Yeah, I think in principle, if you take northern Sweden, it's a bit different for different operators, but in principle, it is coverage on all major roads that are up there now, but it's not coverage exactly if you take where there is no roads. Whereas if you're in sort of the mountain areas, that could be more tricky for coverage for that. But in principle, on all major roads, there is coverage in Sweden, because Sweden as a country has put up a regulation in the norms that there should be coverage for.
Yes, and we hope to see it, but we certainly know that in many, you say, mountain areas far north, if I go to Canada, or even say North Dakota in the US, we don't have coverage, and when the carriers will actually provide that coverage is a question. And that becomes an issue for using communications for safety systems, where you may reach areas without coverage. So you have a good assessment of how effective these kind of efforts will be to really get us ubiquitous coverage?
Yeah, I think, to be honest, I think the previous generation of mobile system has been built up due to where people have been living more, and that has come for as kind of a blocking for certain countries. You seem to have that in the US, that the coverage are not good all over the place in the US, and I understand that, and there's a similar thing in other parts of the world. But with sort of the introduction of the 5G system, and its sort of ambition and creation, and taking into account the needs of various different types of industries, not just the automotive industry or the car industry, but also other types of industries, for manufacturing and other types, even for sort of the utilities like the electricity things, and even for wood manufacturing and farming and so on. That will over time make coverage more ubiquitous. Maybe not completely all over the world. I think that is far ahead. So I think, and we think, that you always have to have a sort of fallback if you go for this totally self-driven autonomous or type of systems. And then of course we have opportunities and possibilities to extend the coverage of the network with other types of, not necessarily having to use a base station on the ground all the time. We can have base stations on this high altitude platforms, which is serving bigger areas. Maybe in these areas we could have base stations on satellites as well. And we have, if we take there is various satellites components, of course, and operators doing this, and we have 3GPPs looking and making standards for the 5G standard for satellites available now. And so there will be different opportunities to extend the coverage, even in very remote areas where you don't have an easy way to deploy a base station on the ground.
Yes, the LEO technology as it rolls out may well be a solution for some of these things, and we look forward to that and how we get LEO receivers that can be integrated with the regular mobile network receivers at a reasonable cost for the car industry, and not just be an additional cost, which is something that many of the vehicle manufacturers are concerned. So that's certainly a useful possibility, and I'm glad you mentioned it. So let me ask a final question. And all of these things, as we talked about, and certainly getting the ubiquitous coverage is going to be one of the costs. I think there are questions. We know that the coverage will help a lot, but how are the vehicle manufacturers going to meet their objectives? Many of the CEOs of the main vehicle manufacturers have made statements that they will have tens of billions of euros worth of revenue by 2030 from services. Where do you think that revenue is going to come from?
Well, I think that is for them to answer, since it's them that have stated that what revenues and how they will get that. But and then, I mean, it's like connectivity for me. It is I can imagine a few things, but I'm not smart enough to imagine everything. Similar, like I'm not smart enough to imagine everything what's gonna happen and what you can monetize and what you can own on the internet. So I think they probably have very good ideas on what to do and how they will, what they will get from that. And in one way, I at least go back to that. Yes, they may earn money themselves, or at least reduce their own cost by having connectivity to get the better car experience for the people that buys the car in one way or another. Whether they can charge directly or not, that is not for me to say.
Yes, that's, like I say, a very, very interesting question that will be, I look forward to finding out how this magic is going to happen. But it's certainly great that we're going to have the technology. Now it's going to be how we get from the technology to actually the economics, where for a vehicle manufacturer who has to pay to provide the technology, how the vehicle manufacturer gets the results. So Per, I really appreciate your time and your thoughts. Very helpful and very insightful. So let's have a virtual round of applause for Per for his great contribution. Thank you. So next,
thank you.
Next speaker will be Frank Han from Chengdu. I recommend all of you to, separate from this presentation, to look on the website where Chang'an, who's been a really great sponsor for us, nicely made Mr. Han available for an interview that had a number of really interesting questions and his answers. The link to that YouTube interview is in the chat. I suggest all of you, when you have time, to look at that interview because you will find it very, very valuable. So consider that, as I keep telling you, more work to do. Please look at that. As I said, Chang'an has been a great sponsor this year. Really appreciate their support. And they've made a lot of this session possible. So Frank Hahn himself is the chief software architect of Chang'an. Mr. Hahn is responsible for the overall technical direction planning of Chengdu's software-defined vehicles. Mr. Hahn coordinates the technical research projects in the software field and leads the design and development of Chang'an's new generation automobile software platform. Overall, Mr. Hahn really is a senior expert in the field of information and communications technology. Mr. Hahn has more than 2 decades experience in the design and development of heavyweight commercial products in the information and communications technology. In a recent IEEE conference, and you can find it by doing a search on Google, Mr. Hahn presented the Vehicle Edge Cloud Open Framework as a new data and AI-centric vehicle software framework, producing much safer, more efficient, connectable, and trustable mobility as a service through cooperative vehicle infrastructure and cloud capabilities and intelligence. Mr. Hahn advocates the use of an Ethernet ring network in the new generation of automotive architecture to meet the real-time requirements of big data and to improve the reliability of information transition. Mr. Hahn led the team that built the vehicle services bus in a service-oriented architecture and realized the all-domain deployment of data distribution services. Mr. Hahn holds dual MSs, one in computer science and one in automotive control systems. So please proceed with Mr. Hahn's presentation.
Ladies and gentlemen, good afternoon. This is Central Han from Chang'an Automobile. It's my honor to be invited to the FNC 2022. I appreciate the opportunity to talk about vehicle and related communication technologies. Today, I would like to share with you some of my understandings and thoughts on how in and out vehicle communications drive the future of new automobile. First of all, I will start by talking about how customer demands drive the transformation of vehicle communication technologies. People born between 1995 and 2000 are called Generation Z in China. They are getting married and start families, making them a new consumer group in the Chinese passenger vehicle market. Generation Z have dramatically different expectations for the roles, functions, and service of the vehicles. They wish the new car to be their third living space, which is easy to use and fun to drive with more applications and service on demand. This drives a new generation of vehicles that are smarter, more efficient, and more convenient. The fast-changing vehicle communication technologies with high transmission rate and high security are gradually being integrated into vehicle production. Additionally, with the combination of information and communication technologies, in the new energy vehicle, we found many valuable evolutions and customer values can be achieved where we couldn't do before at all. Customer new demands have driven the development of communication technologies. The automotive industry changed more like a network instead of a linear chain. Application technologies such as backbone network, short-range communication, and telecommunication network are becoming much faster and more real-time critical. Traditional communication technologies and the new ones were coincident for a certain period of time. Or revolution of communication technologies have created rich application scenarios. The backbone network with Ethernet facilitates the rapid development of autonomous driving applications. It also drives the revolution of EE architecture from function separate to be the computing information centric. Remote vehicle control, closed-loop data service, high-definition land-level navigation, and intelligent decision-making can be realized with high bandwidth and low latency 5G network technology. Cellular V2X communication technology ensures the coordination and safety between the vehicles and the road users. All this brings about the integrated development of intelligence beyond a single vehicle. UWB-based digital keys and NFC-enabled key cards offer customers brand new experience of ingress and egress. In vehicle communication in many years, we will see have both Ethernet and KFD. Ethernet is expanding from the 1 megabit to 1 gigabit, even to 10 gigabits, and accepts the real-time TSN standards to be the new backbone of much higher speed automotive networks. To ensure high reliabilities and low latencies in vehicle communication scenarios, some car makers like Chang'an is building TSN with application across the physical level, communication middleware to the application with a latency of a millisecond. Controller area network will evolve from 2 megabit 5 to 10 megabit, and will continue to play a role in low capacity communication scenarios. The next generation of vehicles asks for real-time, reliable, and secure backbone communication with clock synchronization, which will be important in scenarios such as infotainment. However, problems still exist. Ethernet communication currently is not real-time or reliable enough. The TSN technology is not very mature. Neither is the industry supply chain. For example, the real-time operating system and controller hardware that TSN QPV strongly relies on are not providing enough. The progress of short-range communication technologies such as NFC, Bluetooth, and UWB enables very rich user applications. For example, Bluetooth provides users with entertainment service and smart home capabilities. The NFC key card brings new drive experience, and UWB greatly improved the convenience. V2V and V2I help promote high-level autonomous driving applications by facilitating vehicle-to-vehicle, vehicle-to-infrastructure communications. However, there are issues of short-range communications, including smaller coverage of the new road infrastructure and lack useful common safety-related information models of V2X technology, and the new uniform protocol standards for other short-range technologies either. The rapid growth of telecommunications has driven the development of connected intelligent vehicles. By providing high bandwidth, low latency, high reliability, massive connectivity, and security, 5G network provides possibilities for richer application scenarios and service. 5G has potentials in transmitting vehicle, environment, and other safety-related information, which enables intelligent decision-making and remote driving. However, the lack of large-scale commercial deployments, no coverage at the base stations, and immature business model pose major challenges. to the applications of cooperative autonomous driving in cloud. The rapid development of technology and change in business models have brought new challenges to the automotive industry. The industry needs to be joined together, building future connect, safe, efficient, and convenient vehicles. First, we need to build soft capabilities by accelerating the construction of standard infrastructure, promoting alignment between standards and practice, strengthening cross-sector and cross-regional cooperations, and increasing alignment of application standards. For example, there are multiple standards for short-range communication technologies. We propose that application standards of terminal and vehicle should be unified to lower adaptation complexity. In innovative fields such as autonomous driving, laws and regulations on autonomous driving and readiness security should be proved as soon as possible. The fault-tolerant mechanism should be built to encourage innovation and creativity. Second, we need to build hard capabilities by accelerating communication technology advance and promoting the development of the new industry supply chain, including silicon chip, operating system, and middleware. Also, we recommend that the governments make top-level infrastructure planning for intelligent connected vehicle, accelerating the construction and deployment of high intelligent roads for the safety of autonomous driving. Third, we need to ensure network communications and information security. We need to improve the network and data security development system across industries such as automobile, transportations, and communications, focusing on function security. We should build safer and more personalized vehicles with diversified and differential service for their customers. To ride on the news wave, Chang'an has initiated the third business transformation journey, innovation and entrepreneurship program. We're committed to openness and industry sharing. Join hands with all partners. We want to build platforms and establish a new ecosystem of in and out vehicle communications with joint technology research, uniform standards, open access to the resource, and collaboration. Together, we will establish a new industry landscape of cross-field cooperations for win-win development. We're willing to work with industries to scale up exploration and strive for the revolution and large-scale commercial deployment of the new connected intelligent vehicles. We believe the advance in communication technologies can drive the future of the new automobile industry. Thank you.
Thank you, Frank. A really good presentation. As I mentioned, there's also a very good interview that Frank did. I hope you will find a time to take a look at it. Our next speaker is Vishnu Sundaram, who is the Senior VP of Cockpit and Connected Services at Stellantis. Stellantis, you all most know, is now the merger of what used to be Fiat Chrysler and a collection of PSA, which had acquired Opel from GM. Now, Mr. Sundaram leads the effort to transform Stellantis into a leader in the connected cabin experience. Mr. Sundaram is leading global development and is driving the platform-oriented creation of cockpit, connectivity, and cloud products to bring a plethora of live content and services to the connected experience in order to transform the car into a living space leveraging artificial intelligence, machine learning, augmented reality, immersive gaming, and edge cloud computing services. Prior to joining Stellantis, Mr. Sundaram was the Senior VP and Global Leader for the Telematics Division at Harman, which had been acquired by Samsung, where he drove the creation of cutting-edge connectivity solutions for Harman. Mr. Sundaram started his career at Intel, followed by time at Trilogy. Mr. Sundaram then spent a decade as an entrepreneur, ending with a company in India, Interchange, that Harman acquired a decade ago. Mr. Sundaram completed the Executive General Management program at the Wharton School of Business. Mr. Sundaram holds an MS with specialization in software engineering. Vishu, please go forward.
Hi, good morning, good afternoon, good evening. I'm Vishnu Sundaram, Head of Corporate and Connected Services at Stellantis. I'm very honored to be talking to you in this prestigious forum hosted by ITU to talk about the future networked car. For starters, Stellantis is one of the largest auto manufacturers in the world. We operate in over 130 countries and we have a 14 prestigious brand portfolio where we sell our cars. In our view, cars are evolving very, very fast in the last few years compared to what happened in the last few decades. Cars, from being just vehicles which transported people from point A to point B, is now transforming to be a third living space. The lines are thinning between how people use their smart devices compared to how people expect and use their future cars. Before we go into the details, let me show you a sneak preview of how we envision and develop our next generation corporate experience.
Is the future. It's an evolution. This is the future.
You would have seen a lot of concepts that we showed there. The fundamental pillars of these concepts are cars becoming intelligent, cars becoming always personalized, and cars becoming hyper-connected. And these cannot be delivered without a platform that can be constantly updated and constantly accessed from over the cloud. It's very funny to realize that the whole concept of connectivity was really started off with e-call implementation. Thanks to ITU Group for bringing in the e-call mandate, which really set the stage for cars becoming connected. So this led to all cars massively being connected to have the basic safety call applications on the road. And this evolved into being the platform for over-the-air updates to be delivered to the car. Having over-the-air updates kept the car up to date and helped address the feature gaps that we were able to address to bring cars to be more relevant to our customers. But that's just the beginning. The next generation cars are much beyond that in terms of leveraging connectivity. So the future cars, in our view, especially the Stella Smart Cockpit that we are developing, is going to be built on cloud-first experience. So cloud-first experience is about bringing live, always refreshed, and always personalized and more intelligent than yesterday experience to our users. Cars rely on intelligence beyond what is embedded inside the car. For a long time, one of the limitations that the car had was the ability or the compute storage and capabilities that were embedded inside the car. We realized that we are approaching the physical barriers here. There is only a limited amount of compute storage and capabilities that you can install in a car when we ship the car. But the applications that we can imagine are growing far beyond what we can envision when we design the cars. So this is why we are enabling the capability through connectivity. So connectivity is unshackling the existing constraints that we had, opening the car to access a huge unlimited amount of compute, storage, and intelligence that can sit in the cloud. And this is further enhanced by even bringing in such a compute facility at the edge closer to the car, which helps us deliver near real-time experiences even from outside the car. So our cloud-first experience that we are talking about here is all about delivering comfort, convenience, gaming, productivity, and all these experiences in a continuously refreshed way from the cloud. Apart from entertaining the users with this cloud-first experience and engaging the users with this cloud-first experience, we also believe that connectivity is going to play a significant role in making cars safer. We are talking about the future cars where there will be by default a level of embedded autonomy. The level could vary, but then it's going to make commutes more safer and more stress-free for the drivers. For such cars, it is important for a coordination between other devices that are on the road and also in the infrastructure. So this is where the vehicle-to-vehicle and vehicle-to-everything communication platform becomes a pivotal point for delivering these experiences. Our next generation cars will be powered by state-of-the-art 5G and will also be capable of vehicle-to-vehicle communication to unlock the power of car to not only see with the physically connected sensors, but access or see through all the other sensors that are installed in the cars around by having cars talking to each other in a standardized format. We also believe that cars will in the future become our experience zone. So as an OEM, we look forward to delivering a plethora of content and services through our car. So car is really not only the platform for us, but also the platform for third-party developers and third-party content providers to engage the audience in the car. One more big change that we see is it is not about just entertaining it's not about just providing driving experience to the driver. It's about taking care of experience of every passenger in the car. This is where the high bandwidth capability of the next generation connectivity technology like 5G becomes essential. And also latency helps us move the intelligence from within the car to actually outside the car. When we moved outside the car, we are able to harness the unlimited and nearly unlimited power and nearly unlimited compute and storage and intelligence that we can embed in the cloud. Is all that a walk in the park? No. I mean, there's a lot to be done. As an OEM, we are pre-enabling the car with the right hardware, and we are building a scalable software solution that can help us grow the capability even after we ship the car. For the whole experience that I shared with you to come alive, there is more to happen at an ecosystem level. First of all, we are in an early stage where we are talking about cars talking to other cars. So this has to go through a process of standardization, and also the entry barrier in terms of cost for enabling these connected experiences should fall significantly, so that we don't look at connectivity or cost of connectivity as a barrier towards delivering these experiences. And for us to bring all of this into a forum, I think ITU has a big role to play here. Thank you for bringing eCall to start with, but now I expect ITU and organizations like ITU to play a big role in bringing auto manufacturers together, in creating standards and creating the necessary mandates for us to bring the technologies to mainstream. With this said, I'm very confident that the future cars are going to be differentiated only by the experience and the capabilities that are embedded inside. And this is not going to happen without the connectivity as the backbone. So we really look forward to working with all the ecosystem players in the connectivity area, be it hardware, software, services, content, to create this enriched platform for our customers. I thank you one and all, and look forward to being in the panel to answer your questions. Bye.
Yes, thank you very much, Vishnu. That's a really great overall coverage of what's happening at Stellantis. Our next speaker is Johannes Springer, who is responsible for the 5G automotive program at Deutsche Telekom. Mr. Springer joined Deutsche Telekom in 1998. At Deutsche Telekom, Mr. Springer worked as CTO, COO for Toll Collect and was Vice President Technology and Solution Design in the Connected Car Business Unit of T-Mobile. Previously to Deutsche Telekom, Mr. Springer was in charge of Institute of Aeronautics and Industrial Engineering at RWTH Aachen University. Mr. Springer represents Deutsche Telekom at 5GAA, where he's been engaged in various projects and working groups since 2018. Mr. Springer is the Director General of 5GAA. Mr. Springer holds a doctorate in mechanical and production engineering. So Johannes, please go ahead.
Yeah, thank you very much, Ross. And as I'm live, hopefully everything works properly. I'm sharing my slide. If something goes wrong, please step in and give me a short note. Yeah, thanks also for the whole ITU to have me here today. I'm representing today also, of course, the 5G Automotive Association, and I would like to give some insights what we are doing at 5GAA to make all these nice things happen, what we have heard already so far from Per, from Frank, from Vishnu, and most likely also Nakul will give you some insights later on. So I think what in essence everybody has recognized, that the future of mobility is a connected mobility future. So we need to rely on the fact that we as customers, whether we are sitting in the vehicle as drivers or passengers, or whether we are using other types of mobility like pedestrians or cyclists or motorcycles, even sitting in a bus or a train, we want to have everywhere, anytime, connectivity. And with that, of course, a lot of use cases will be happen and can be made happen. So does it work? Yeah. What do I want to talk about? A bit short, very brief introduction of 5G Automotive Association. We have already seen a very nice video from Per, who we are, what we are doing, and why we are there, of course. Then a short explanation of what is CV2X, You have already, of course, also seen the video, so I can make this very short. I would like to concentrate on that what we are discussing very intensively today in all the various fora, and these are the 5G capabilities. So what brings 5G as an add-on to cellular coverage and to cellular connectivity for connected and automated driving? And finally, of course, also Ross has already asked this question, and that is how do we make money out of it? What are the use cases which can be monetized, which of course then also justifies all these huge investments on the car industry, but also on the mobile network operator industry. So who we are an association which was founded 5 years ago. So we are celebrating this year our 5th anniversary. And we are bringing the automotive industry and the telecommunications industry together. If we are talking about connected and automated mobility, of course, this clearly indicates that we need the car industry with all their suppliers, and we need the telecommunications industry to work very closely together. And that is not only about collaboration between some partners. We have also heard from Per, if we are talking about automotive industry, that is really a global industry. So we as 5GA are a global cross-industry association. Now have 13 of the 15 top OEMs on board, 9 of the top MNO, 10 of the MNOs on board, and 3 of the top smartphone vendors, including the technology which is essential. As I said, we were founded 5 years ago with 8 founding companies. We are now more than 120 members, and even growing in that difficult times. So what is C-V2X and what is the technology we are relying on? And that is very important to understand. And you have already seen this video that we from 5GA, but also we are taking the terminology from 3GPP standardization. The C-V2X integrates the UU, the cellular communication part, with the direct communication, the PC5 part. And of course, with that being mobile on the roads, but also somewhere else, we can improve the mobility ecosystem as such. And if we are looking a bit more into the details of this automotive connectivity landscape, then of course we are not only talking about the vehicles on the road, but we are also talking about the other traffic participants on the road, which are creating specifically in the city, specifically in urban areas, also a lot of safety impacts. So these are the most critical fatalities in each of the cities around the globe, and of course we need to address them as well. So the vulnerable road users are a very important part of this ecosystem. And of course, the mobile networks, which are providing, I would say, the glue to transmit all this kind of data and information between the various parties. And of course, what is also very important, the traffic infrastructure, the road infrastructure, whether these are traffic lights, variable message signs, roadwork indicators, and other stuff. So what are the important topics when it comes to C-V2X and connectivity issues? Of course, we have the direct communication. You see this here on the lower part of the slide. In more and more cases, we are talking about, and we need to face the need for quality of service. And with that, of course, 5G offers us and brings a lot of new technologies with respect to network slicing and different network APIs which can be offered. We are talking about mobile edge computing. This is already deployed in various networks, and we are now intensively discussing in the 5GA how to make use of this infrastructure also in a multi-operator domain on a global basis. We are talking about precise positioning and positioning integrity, so not only connectivity, but also using the connectivity channel to get access to different correction services which are available around the globe. And of course, we need to organize the access to the traffic infrastructure because it provides a lot of valuable data and information, which is important for the vehicles, but also for the other road traffic participants. So we have one very important, I would call it synchronization tool, which we are using in our discussions inside the 5GA, and that is a so-called CV2X use case timeline. And you can see here that, of course, some of the use cases are already there in the market, local hazard and traffic information. I will give you a short example on this, but also use cases which are very near on the horizon, but or will come in the next upcoming years into the market. For instance, automated valet parking, or this type of HD map collection and sharing for automated vehicles level 3 and above, or other types of use cases, like for instance, complex interactions between various traffic participants. So just to browse very briefly through some use cases, that is a use case which is already there in the market, and we are working also intensively, specifically in Europe, to exchange this type of information between various traffic participants, not only within one brand, but of course also between other brands. It is clear that the following vehicle with a limited vehicle sensor coverage can benefit from a vehicle which detects a certain issue on the road, whether it's a black ice situation or whether it's a pothole situation or something like that, transmits this information to a location platform. The location platform makes a lot of data aggregation and processing and downloads then a service or gives access to a service to the following vehicles so that they are informed properly in advance and that they can adapt their behavior in advance properly. So the same, we are doing also a lot of stuff with regard to edge computing. This example we have seen earlier is not something which is that much latency critical, but of course reliability and availability of the service plays a crucial role for such kind of a service. So we have right now live trials ongoing, also in the recent days in Blacksburg, Virginia, or here with the example in Turin, where edge computing plays an important role to avoid collisions between the vulnerable road users here, cyclists, and the car. And we have the same example deployed here together with Continental in the Deutsche Telekom network, which provides the collision information and the collision warning information out of an edge cloud application. When it comes to quality of service and quality on demand, it is of course essential that if the network plays a crucial role for the use case, then we need to talk and we need to organize quality of service in the mobile network. So the best effort operation principle of the past is not something we will see in the future for such kind of mission critical services. If you drive a vehicle remotely via a cellular network into a free parking spot, a so-called automated valet parking use case, then of course we need to rely on the availability of the mobile network, and that's exactly what quality of service will bring to us. The direct communication, we have seen great examples around the globe. Here an example from Audi together with Applied Information, where they are using the direct communication path to warn the driver from a stopped school bus so that the kids are running out and might create a severe accident. So also a good example of which what type of added value these type of technologies will bring to us. And of course, we can also use the information out of the traffic infrastructure. Here in that example, the traffic lights. This information, this service is already available also in an Audi in the US, but also in Europe in some of the cities. And this example shows also how strong is the collaboration need with the road operators. Per has also indicated this in his introductory speech. A strong and very close collaboration to the road operators, that the information which is available in the road infrastructure need to be accessed by the cars, but also by the other traffic participants, is of utmost importance to create or to provide such kind of service. Finally, Russ, you have also asked about how does the data plan of the end customer plays also a very important role. And this leads to such kind of use cases. What type of data stream is monetized or needs to be paid by the vehicle, by the car manufacturer? What type of data stream needs to be paid by the customer? Does the customer any longer accept this type of, let's say, split world where he needs to care about where the connectivity is providing to make this integration of customer connectivity as smart as possible? This is already available also in some of the vehicles, of course, not in a mass market manner, but we know how to do it. So now the job is on us to make these type of infrastructures happen and available to a broad customer group. So with that, I would like to thank you again and looking forward to the upcoming panel discussion. Thanks a lot for your attention.
Thank you very much, Johannes. A very interesting and helpful presentation in laying the basis. So our final speaker is Nakul de Gaulle. He is Senior Vice President and General Manager Automotive for Qualcomm Technologies. Mr. de Gaulle is responsible for Qualcomm's automotive strategy, automotive semiconductor and software portfolio, ecosystem development, program management, and customer relations. Mr. de Gaulle's responsibilities include focused development and expansion into the digital cockpit, smart transportation, and the connected car, as well as autonomous driving, oversight over product roadmap and its execution, customer-focused business development, and application engineering. Mr. de Gaulle has worked at Qualcomm Automotive since 2011 and has been instrumental in building Qualcomm's automotive portfolio and global footprint. Mr. de Gaulle joined Qualcomm in 1995 as an engineer focused on the company's commercial base station and infrastructure business. Mr. de Gaulle holds a BSEE and an MBA. Please go ahead with the presentation.
Hello, everybody. My name is Nakul de Gaulle. I manage the automotive business at Qualcomm. It's a pleasure to be here with you a second year in a row at the Future Networked Car Symposium. I'm here to share my thoughts today with you about monetizing the connected car. There is so much that is going on in the automotive space. I think one of the most important aspects of the conversation is how will automakers monetize the platforms that they are heavily investing in over the coming decade. Software is a central part of how monetization will happen. So my thoughts will mostly be centered around how the car architecture is evolving and moving towards a software-defined vehicle. The car has gone through a variety of different architectures. In the past, as we were thinking about Vehicle 1.0, it was mostly functionality that was centered around mechanics of the vehicle. There was very little in terms of digital content. Customers didn't really have access to using much of the electronics other than a radio. It was mostly focused on customers that were looking to get performance out of the car, that was focused on the mechanics of the vehicle. Over the last 5 to 7 years, as cars started to become more digital, the use cases were focused around music, around navigation. But the experience that you got in a vehicle was quite different from what we have become very accustomed to with smartphones and tablets and televisions. The transition that we are in the middle of right now is where a lot of what we start to see in our daily lives, in our workplace, in our home, those experiences are coming into the vehicle. A lot of newer experiences are entering, whether you think about driver assistance, bigger displays, more entertainment inside the vehicle. But this software transition that has started to happen is bringing about a completely new way of thinking about what the car architecture looks like. The car becomes much more dependent upon high-performance semiconductors. The car has to think about what the life cycle of the vehicle looks like, what the new dependencies are, what new ecosystems come into play, and how do you really manage this very complex transition from being very hardware-centric to start to become software and semiconductor-centric in terms of the life cycle of the vehicle. As you start to look at Vehicle 4.0 or the software-defined vehicle transition, What it really means is that every element of the vehicle that is being designed has the equivalent of a digital twin in the cloud. You have to be able to manage every component, every functionality, every microcontroller, every large processor, and the functions that they are there to provide to have a software proxy. And I use the word software broadly, but really the ability for the data, the ability for the attribute that is being managed to become a software-defined vehicle. This is going to create a tremendous amount of value for the automotive industry, because as the transition to electrification happens, the electric vehicle platform is going to have a much longer life cycle than the typical platforms that we see in the combustion engine vehicle. This will mean that there will be many owners of that platform over the life of the asset, which means that you have to be able to monetize the asset over a much longer period, which ultimately requires a lot of flexibility that the software-defined vehicle will attain. So let's talk about what this actually means. So if you think about what we have been seeing inside the vehicle in terms of the various use cases, and you look at a simple example like electrification. As a car, as a truck, for example, starts to become electrified, the question for, say, in the enterprise for a commercial fleet truck owner would be, what is the right time for me to start to move from combustion engine trucks to electric vehicle trucks? What are the determinants for making that decision? Well, you have to be able to understand simple things like how much would you save if you move from a combustion engine to an electric vehicle? You have to know what routes you're driving. You have to know what kind of charging station capabilities exist there. You have to know what kind of driving your vehicles are doing so that you know whether you'll be able to get the same performance throughout the year. You have to know what kind of battery capacity you need to have in place so you know how many times you have to go charge. And there is a business case across all of these aspects that will allow you to make that decision. Well, this information is not information that is readily available within the automotive ecosystem today. It requires dependencies on a much more complex ecosystem. You need to understand mapping. You need to understand the data that you're getting off of your vehicles and how the data is processed. You need to understand the implication of insurance on this. Dealers have to understand how to go sell this type of value proposition to their customers. So a lot of new pieces of information need to be available for an automaker to be able to make the case for a specific new feature that is being introduced. If you look to the right, what this means is the vehicle is no longer identified by just the data that is on the vehicle. You have to connect that data to a variety of different ecosystems. So what does it mean for an insurance company when they have to go insure an electric vehicle? What if the vehicle is being used for commercial purposes versus as a passenger vehicle? What does it mean for a digital content company to serve digital content into the vehicle? Who do they target? Where is that information coming from? When you then pull all the way back to how a car is being designed or a car is being marketed or where an automaker invests in terms of new car models, what kind of information is needed? So this closed loop feedback system is something that is being developed today. It doesn't exist in its entirety. Newer EV manufacturers that did not have any legacy are farther ahead, but every automaker is really moving towards this transition where they're trying to figure out what are the areas that they have to invest in to be able to go take advantage of this. And for companies like ours, this is an interesting opportunity. This is a new opportunity that allows us to be able to focus on newer areas of investment where we become much more relevant to our automaker partners as well as the tier one ecosystem. So if you now think about an electric vehicle in the context of this massive change that is happening, every electric vehicle is going to have a much longer usable life than its counterpart on the combustion engine side. This also means that the electric vehicle is going to have many different owners. Now, if you have a platform that has such a long usable life, you have to be able to make sure that the software that is running on this vehicle has value to the various owners over its life. Not only do you have to think about whether the hardware will be relevant, we are now seeing architectures where you have the ability to be able to upgrade the physical hardware in the vehicle over its life, but you have to also be able to think about the software and how the software architecture evolves. The software architecture has to follow the use cases. What will the vehicle be used for? Who's going to pay for that specific use case? Do you make a different determination whether the vehicle is a fleet vehicle versus a passenger vehicle? How do you adapt the use cases depending upon which part of the world you are selling the vehicle? What kind of interaction does the vehicle have with its environment? Car to car communication, car to infrastructure communication. What kind of data do you need to get off the vehicle to be able to make all of these cases? And all of this makes the point that for you to be able to figure out what kind of features, what kind of use cases the vehicle will have, it has to have a software-defined vehicle architecture. Which brings me to what the next generation vehicle architecture is going to look like. When you define hardware today, the hardware is being defined keeping in mind what the use case is that the customer is going to be deploying over the next 2 or 3 years. We are already starting to see requests from customers where they want to make sure that there is headroom in this hardware such that the vehicle platform is relevant for the next 5 years, the next 7 years. The architectures are now always shifting towards a scenario where the hardware is no longer bolted down. It is a card, it is a module that can actually be upgraded over the life of the vehicle. If you then shift your focus on software, the software is highly modular. So you define software where there are pieces that are sitting on top of the hardware that have to be robust, that have to meet the quality requirements, that have to be extremely ruggedized in terms of the basic use cases. But as you start to go higher up the stack, as you start to think about applications, the applications are cloud managed. The applications have to be very flexible. They have to be updatable continuously. They have to be able to change depending upon new features being introduced, depending upon bugs being found that can be upgraded overnight. And this entire experience is going to ensure that there is flexibility in the underlying asset that the automaker is developing and selling for the variety of use cases that it is relevant for, and also for the period of time that the vehicle is going to be on the ground for. We have a variety of different solutions as we start to think about what we have to go do in this space. Where it starts from is the idea that today's traditional value chains are highly fragmented, where you are purchasing as an automaker a variety of different portions of the solution statement from many different suppliers. This makes sense in the scenario where you are not looking to necessarily update the platform on a continuous basis. The approach that we have now taken, for example, in the case of 5G, is we are organizing our entire partner base such that we can provide our customers everything from the capability of being able to enable 5G in the vehicle through a NAD, for example, working with our tier 1 partners. We work with our global MNO partners to be able to provide the connectivity and the airtime, so the SIM cards that will enable 5G. And then we work with a variety of different global service providers so we can provide device management capability and the various services that have to run on our devices. This allows automakers to be able to work with us to get access to our Qualcomm connectivity as a service solution that makes sure that as we start to think about the needs of our automaker customers over the next 20 years, we have the ability to not just understand what they will need for the next 5, but when they think about upgrading to the next G technology that comes along, for example, we know what portions have to be updated physically and what can still be retained so that there is the investment that they are making that can be leveraged, that can be taken advantage of over multiple generations. Very similarly, as you start to think about our car-to-cloud efforts in this space and extend what we talked about in the context of 5G up to the application layer, we are building solutions that allow us to be able to offer to automakers the ability to write application software independent of the underlying hardware that is being used. This allows a number of APIs, a number of abstractions that we are developing on top of our hardware, such that the software that our customers are writing doesn't actually care about the underlying hardware. This creates the ability for them to be able to distance themselves from the underlying hardware and simply focus on the use cases, the differentiation, etc. that they're doing. Now, we're not doing this by ourselves. We work with a variety of our partners. We've announced partnerships with Cubic Telecom and Cognizant here in the last month or so. But there are several partners that come together to allow us to be able to go build these capabilities. And finally, the value of this is really to the entire ecosystem. We are looking at all types of transportation verticals, all types of applications, from fleet management to predictive maintenance to electrification, logistics and tracking. We are also looking at a variety of different pre-integrated services that we are implementing with partners, whether it is precise positioning that we implement with our MNO partners, or alarm notification, remote engine disablement that we apply with various automotive solution providers. And this allows us to be able to connect our solutions end to end for customers to be able to develop their applications based upon our APIs, for us to be able to manage these platforms through our car-to-cloud efforts, and then finally to be able to engage with a variety of different partners to be able to go build these new solutions. I'd like to end by mentioning that this transition that we are seeing in the automotive space as the car becomes a software-defined vehicle creates a tremendous amount of opportunity for a variety of different players to be able to take advantage of this platform that we are in the middle of rolling out with many of our automaker and tier 1 partners. Thank you very much, and I hope you have a great set of meetings.
Thank you, Nicole. A very good basis now to lay the foundation of what will be the panel discussion. So we will now take a quick 10-minute break and then resume with the panel of 4 speakers, and we'll handle questions as you present them in the Q&A. Thank you. Thank you, everybody. We're ready to get going with the panel. I appreciate the great presentations and look forward to the discussion for the next hour. So I want to start for everybody. My first question, please feel free to speak up, everybody. We've heard lots about technology, lots about 5G, many things that are going on that we know are going to come into vehicles. These technologies will require the vehicle manufacturers to install communications equipment. Many of them are doing it now. Almost every vehicle manufacturer says they will do it in the future. Key question that I have is, vehicle manufacturers have to spend a lot of money doing this. What is the revenue that the vehicle manufacturers are going to receive from having these technologies in the vehicle? There's lots of things that will make life easier for customers, but not clear where that they will pay it. I hope that it turns out that there'll be substantial revenue, and I'd like to hear from the panelists where they think the revenue is going to come.
Russ, Vishnu here. I could probably give the view of auto manufacturers here. First of all, thanks to all the technology players in the ecosystem. So they have lowered the entry barrier that was there to bring the latest technologies into large scale adoption. But it comes with an investment into enabling the cars to bring the capability for the future services. As an OEM, in our view, we look at revenues coming from 5 pillars. The first one is services and subscriptions. So there are a lot of services where we can provide additional value, including entertainment, including productivity services that can help us build a revenue pipeline. And then feature on demands. So our future cars would be configured in such a way that part of the features, additional features, will be activated on demand with new business models, per trip business models. And then there is a lot of fleet services that can also benefit from having the next generation connectivity in solution. And the fourth one that is important is in keeping the car relevant. Cars lifespan is going to extend beyond what is today, especially with reduction in old generation mechanical combustion engines. So with all electric propulsion, there are lesser moving parts. So cars will be there on the road for longer, and maintaining the resale value by having the right technology inside the car, that's also important. And last but not the least, cross-selling opportunities where we can bring additional sales through our third-party content providers. So that also is an important part. So it's a combination of different elements within of these pillars. Of course, there is no one single service that's actually going to help us generate these revenues, but a combination of these is what we are expecting to help us recover the investment that we are making in hardware enabling the car.
Okay, Nicole, you are, I think, one of the suppliers to GM. I think you may have seen that Mary Barra, CEO of GM, a little while ago said that GM was going to have tens and tens and tens of billions of dollars of revenue from services in 2030. What do you think? Where do you think that revenue is going to come from?
Well, good morning, Russ, and good to be with you. I think Vishnu's response in terms of what encompasses the various revenue sources is spot on. Look, I think this is not so much a question of you add 5G to the vehicle and how do you make up for the cost of adding connectivity. I think there is a bigger transformation that is at play. The car is moving towards a software-enabled platform. And when you go through that transformation, when you go through that transition, you have the opportunity to be able to think about the use cases of the vehicle from a very different vantage point than what has traditionally been done. All of these use cases, and you see a lot of this today in our daily lives, you see it in the home, you see it in the office. If you create the opportunity to be able to find use cases that are software enabled, that are services enabled, and you are talking about implementing these on a platform that is a platform that is being used by people for their livelihood. Think about ride sharing. It's being used by commercial fleets. It's of course being used as a passenger vehicle. The opportunity to be able to extract value over the life of this platform is enabled through a connected software platform. So I think the opportunities are endless. The challenge is that a lot of this requires automakers to reorient themselves from being hardware manufacturers to really platform manufacturers, where software is a very large component of the solution. So I think in terms of where the revenues come from, I think we can do the math across the various subscription services, the various fleet services, the longer term value that a platform has if it is bought by a commercial fleet. And I think those numbers do start to add.
Nicole, that's, I think, absolutely right in theory. But I think you've dealt with vehicle manufacturer purchasing agents for a long time. And the tendency in the past has been that the purchasing agents squeeze the equipment down to the minimum. How do you see this changing? Do you think that vehicle manufacturers through their purchasing process will actually be able to put substantial additional equipment into the car, more memory, more processing power, more capabilities, to be able to make use of the evolution of technology so that you can actually capture the revenue by doing the kinds of updates that you mentioned?
Yeah, so I think a few things are changing very rapidly. I think one is that no automaker is thinking about designing a platform whose usable life from a digital perspective is 5 years or so. Everybody is thinking about rethinking what the usable life needs to be. And that means you have to think about adding more performance into semiconductors, into the scale of the platform itself. You have to think about how you potentially even plan for a hardware upgrade midlife through the life of the vehicle if hardware goes obsolete. And those discussions are happening right now. There is absolutely an increase in cost of the electronics that are going into the vehicle compared to what they used to be 5 years ago. What is also happening, though, which is quite well known now, especially through the semiconductor crisis, is that the relationships between automakers and technology suppliers like ourselves is become much more proximate. So it is no longer a situation where we think about the partnership as a single generation partnership. It is a multi-generation partnership. We understand that the auto industry is going through a tremendous amount of transformation. And to find these new pockets of profit is going to take time. So you have to be able to think about investing in the partnership for the future while keeping in mind that you have to be part of the risk taking that has to go on as automakers go through that transformation. So these are highly complicated times. The economics through this change for an automaker are highly complex. And for someone like us who's thinking about this in terms of what the long-term vision is, we have to be able to balance immediate needs that we have on our P&Ls versus what the long-term strategic value is in helping the transformation happen.
Yeah, Frank, what is Chang'an doing in this area and looking towards having future vehicles, having platforms with extra capability, more processing power, more memory, other things to be able to add future applications?
Okay, yeah. So actually, I think the Tesla already done the some kind of similar things already, right? So it's not just the discussion topic, right? Just a matter of how innovate your technology will really put the real the values to the customers. So the fundamental things is that how can you OEM automaker to put up the right products to satisfy the customer experience. So from the China side, in short term, actually for our new car, we actually transform our product form from the function fixed function based to the function plus service package. Okay, so those service packages includes like the people care, the vehicle care, the hardware plug-in, for the young people, they really like sense of the technology and the science stuff. We also have the service bundle for the navigation for highway, high level autonomous driving stuff, right? Package also for the city driving. That's for our short term in couple years. From right now, in 2030, near time, we think we even have a bigger plan for that, because we really think a lot of time the product form will have big change. Okay, we think the car is not only for the transportation tool, it's going to be transformed to the mobile robots, right? It's going to transform to the mobile data center, because we got a lot of computing, the storage power within the intelligent connected car. So try to think about if we have our fleet 2 million to 10 million vehicle cars. That's going to be really big mobile the data center service provider in the world. Right, so there are a lot of imaginations. We will also think that the new car is a kind of the energy the storage unit, right? It's also potential storage unit. It also can be act as the data acquisition the unit, right? There are a lot of potential the consumer market, also for the commercial vehicle market as well. So there are really a lot of imaginations. Just a matter of how can we come out with the right products to really give the customer the real values which they're willing to pay.
Vishnu, you've now worked in the automotive industry between Harman and now Stellantis and the predecessors, quite a few years. I'm sure you've experienced pressure from purchasing to cut down the amount of hardware. Do you see that changing in the future, and you're confident that Stellantis in the future will be able to do, as Nicole said, put in the capacity to allow the upgrades for the next 10 years by having the extra capacity, like I say, memory, processor, etc.?
Yes, Russ. This is happening as we speak. The ways we work internally in terms of preparing the investment versus return models are going through transformation. So we initially were targeting to recover the cost of the enablement only during vehicle sale, but now we are really thinking ahead and also looking at what are the investments that we need to make today to generate a revenue, much bigger and more profitable revenue in the future. So from that point of view, the next generation products that we are launching are over designed from today's point of view. So we will not be using many of those features at launch, but we are hardware enabling them so that we can generate these revenues through the lifetime of the vehicle. So there is still pressure to keep the costs low. I mean, we cannot increase the sticker price of the cars every year. We have to keep it at the segment they belong to. On the other hand, there is definitely openness and a vision inside the organization to think about future revenues and orient the technology selections based on that.
Yes, your CEO has been very clear about the issues that the prices of vehicles are going up too much, particularly with electrification, and that something has to be done to handle that. So I will be interested to see how it goes. Johannes, do you have thoughts in this area?
First of all, with my head of Deutsche Telekom, of course, once the communication module is in the vehicle, the data plan for the vehicle is very flexible. So it can be easily increased or decreased up to the needs of the car manufacturers who are paying for that part of the data plan which relates to the car related services. Of course, we need to find a way how the data consumption of the customer who is produced inside the vehicle can be split if we only use one subscription, or if we are using dual subscription mode, then of course it's pretty much easier. But even in using one subscription, we can easily split the traffic which is related to the customer and the traffic which is related to the vehicle. And as I said, this is a data plan which is quite flexible, so it can easily breathe according to the needs of the car, but also, of course, according to the needs of the customer.
Okay. Will be very interesting to see. Nicole, let me put you on the spot. You obviously know that Tesla has been driving many of these things. And one of the things that Tesla has done is put in the hardware, all of the sensors and others for their advanced safety products, FSD or what have you. However, they're not requiring it. So they're making a whole lot of cars that have literally, I think, thousands of dollars worth of sensor equipment on them with the plan they're carrying out to have the actual car buyers independently subscribe to the software for those capabilities. Do you see that kind of thing happening with other vehicle manufacturers, where we're talking, not just talking about maybe a couple of $100 or more for extra processing and memory power that can allow things, but a whole sensor suite that could be literally thousands of dollars worth of costs, on the hope that enough people will buy it instead of making it a trim level or other option?
So I think simple answer is yes, we do. And I think the reason why this works for Tesla is because their starting point was highly homogeneous in terms of having a lot of similarity across the various vehicle types that they have manufactured. There is a lot of commonality in design, a lot of sharing of architecture. And really, when you are a small company starting to grow, you actually need the economies of scale for your supply ecosystem to support you. I think the strategy that Tesla has, where you have a common platform and FSD is part and parcel of that platform, is obviously a well thought through strategy. But if you think about the sweet spot of where they are in terms of the types of vehicles that they are selling, it really comes down to where the activations are happening the most, which parts of the vehicle are getting that activation. But they're able to get a tremendous amount of data from those vehicles, because even when you don't subscribe to the feature, the vehicles are always collecting data. They're always sending that back. The overall system is learning, so you have a continuously improving experience. One thing that is important to highlight is that when it comes to driver assistance and automated driving, the amount of learning that you have to have in place is a very substantial part of the quality of the experience that you will build. So unlike other solutions where you simply have to have the real estate in the vehicle and then the performance headroom available for new applications to be ported over or presented to a customer, because their use cases might be different, ADAS is from that perspective quite different as a use case. I think the other piece that is interesting to keep in mind is that there is some religion around sensors, and which sensors are necessary, which sensors are maybe nice to have. And to your point, Russ, about the cost of sensors, I think the more diversity that you have across your vehicle types, and the more aligned you need to be in terms of following certain regulatory requirements, that creates actually a lot of fragmentation in terms of the sensor types that you have to be able to put into place. So it's a different problem statement in my mind when you have an automaker that needs to service a very diverse set of tiers of vehicles, all the way from A-class vehicles to D-class vehicles and even below. The types of capabilities you have to plan for simple driver assistance versus advanced automated driving is a much broader spectrum that adds a lot more cost, adds a lot more SKUs, adds a lot more validation. So, a Stellantis would have a different problem statement than a Tesla would in terms of the affordability on a per tier basis versus the complexity of the sensor suite and the software, et cetera, that is added on top.
Yeah, Frank, Chang'an obviously now has been looking at and working towards moving to electric vehicles, and the ideas of all the connectivity that goes with it. And in China, Tesla has been pretty successful in its market share and become the leading seller. And then you have Xpeng and NIO and others that are also competing, and they're competing in the high-end market. Chang'an core business is medium price vehicles. How do you see the difference in how things evolve for the medium price vehicles in these kind of areas versus the high-end, more expensive vehicles?
Russ, that's a very good question actually, and that's the system we're working on right now. For intelligent connected car, for traditional car, with the composition in the engine, we cannot put too much cost on it, right? Because it just cannot, they afford to do that. So, but for the EV electric car, we actually, take a different route. for to offset the hardware cost, because you have to do the real architecture renovation in this area, just as the Nakul just talked about. Because Tesla, even Tesla, they spend like more than 10 years do a lot of kind of architecture related innovation, the technology kind of the advanced stuff. So for our time, we actually take some major change for our EE architecture for the EV car. So we actually transit from the siloed separate domain, the EE architecture, to centric computer the centric the EE architecture. So we also do a lot of the software, the layouts. We come out with our SDA architecture, we call software defined architecture. So this, software, the stack actually span from the hardware chip, the controller to the operating system, the middleware, the application algorithm to the cloud. So we actually, build this whole renewed software architecture to come up with common, platform for all of the the electric brands. They can share this software, the platform. Okay, and that's the one since we're doing. Another thing that we try to, because as you said, China it used to be middle price market leader in in China market. For our EV, we try to scale up our the brand up to move to like 20 thousand 200,000 RMB market is around the 4 to 5 40 to 5,000 US dollars. So in other markets, we actually really work hard to come out, design our new products, because in China there are some new generations we call Generation Z. This young people, they born in 1995, between 1995 to 2000. Those young the people there have quite different the consumer the thinking as their older generations. They're willing to pay it for the real the real product. They are actually born in the the internet bubble area. They actually come with those internet habits, right? So they're willing to pay for like just like Chan come up with the high level the autonomous driving capabilities sales package, right? From the survey that we can see in those Generation Z people, that about 40% people, they're willing to pay the capabilities that autonomous driving have can provide for them. So I mean that is really depend on how good your product will be, and the customer, they really have started to really willing to pay the additional the money for the things they really care about, right? So that's the two very important the points for Chinese market.
Hey, thank you, Frank. Vishnu, Stellantis has a limited number of sales of high-end vehicles. Maserati, some of the Ram and Jeep vehicles get sold at a pretty high price. But the large majority of the Stellantis sales, I believe, are on mid-price and lower price vehicles. How do you see how your company will approach things versus how somebody like Tesla or maybe BMW or Mercedes or what have you, who can concentrate on single platforms and high end. How do you look at handling these things, particularly the kinds of capabilities that are needed to upgrade a Peugeot over a 10-year period versus upgrading upper end Maserati or upper end Ram?
Sure, Russ. Yes, as you pointed out, I think our diversity is our strength. So we cover a large breadth of the market. When we cover such a breadth, one platform for all cars is not the best model for us to equip the vehicles. So we actually internally have 3 vehicle platforms. So we map all the classes into one of these 3 vehicle platforms in terms of EE. And we have different levels of feature enablements that are in the roadmap for these vehicles. So it is also related to the amount of pre-invest that goes into these cars through sensors and also additional compute. So the levels of feature enablements through the air will vary between premium cars and in-stream cars. But on the connectivity front, we are more or less trying to make it democratized. We believe that connectivity is an enabler for even the low-end cars to access additional compute storage through the cloud. So one way for us to bring new features into these low-cost cars is to move out of the dependency of the resources physically installed in the car. So that's a strategy that we are applying for low-end cars. And clearly, connectivity for us is an investment area where we want to future-proof the car to act as a medium for bringing remote and edge capabilities into the car.
Okay. Nicole, do you have thoughts in this area of the struggle between what are high-end manufacturers and ones who have to have multi-level solutions?
Yeah, I think it comes down to the type of updates that you have to plan for. Given that there is so much of regulation around all of the functionality that is being introduced into vehicles, keeping software updated is in some sense a mandate. Today in our business, we've been in the connected car business now for 21 years. I recall even as recently as in 2020, we were updating software for products that we had shipped in 2007. So as in a tier 2 capacity or a tier 3 capacity, we have engineers that are there to support our products on the long run. I think there is a difference between having to manage software for supporting a business case versus supporting the base functionality of the vehicle. And obviously the logic is going to be different for both. But I think, frankly, it comes down to how the vehicle is being used and what level of flexibility you have to plan for in the vehicle. Also, and this is going to take time, it really comes down to how is the software designed for the vehicle. So if the software is designed where it is highly embedded and integrated, and the complexity of change actually requires a significant amount of validation, that is going to be a tougher business case to pull through. But we are now starting to see for next generation vehicle platforms a transition towards a software-defined vehicle architecture, where you allow the underlying low-level software, the virtualization components to be tightly coupled with the hardware, and you keep the upper layer applications somewhat independent so that you could update one without disrupting the other. These are obviously complicated topics. They are managed differently across various OEMs. but there is clearly a realization across the industry that the architecture has to evolve to something that does not cause the huge amount of validation that is needed when you change software in the vehicle. I think the other piece that I would say is that, to your earlier question about newer automakers versus traditional automakers, changing software on a daily basis is something that traditional automakers would still consider as a big challenge, because at the end of the day, you are changing functionality. I think a lot of automakers have moved past that point and have now started to push software updates to vehicles on a very regular basis. In the future, I think software updates to vehicles are going to happen on a continuous basis. So then the question really comes down to the architecture that you're building. Is it homogeneous enough that the same common architecture can be reused as broadly as possible across as many vehicle tiers, so that this isn't something that is even worth a discussion topic? It really just comes down to how do you manage software platforms going forward for a vehicle?
Yeah, and Nicole, I agree with you. And as we've seen in decades of the automotive industry, these things all eventually happen sometime. And the big issue is who does it properly at what time, through the costs and through the evolution. So let me ask a follow-up piece on that. You know that there are now problems in the US, or a situation where cars that were built with 3G capability are now under pressure because 3G is getting discontinued. The future vehicles that I know about are still looking, though they're going to put in 5G, are putting in 5G as a 5G capability. Where do you see the evolution in the software-defined vehicle to move to the capability for the communications module to be a software-based module with software-controlled antenna filters, so that as 6G and 7G come along and new frequencies are turned on, et cetera, that we will really truly have the ability to update vehicles over 10 or more years?
Yeah, so it's maybe a complex question because it touches upon many different, sometimes conflicting trade-offs. If you think about the transition that has happened over the last 5 years or so, there was a big push towards a smart antenna architecture, where you tried to reduce the cost of antenna cabling and move the modem functionality as close as possible to the antenna. And that created smart antennas where the modem and maybe other tuner capability, Wi-Fi capability, V2X, all sat within the smart antenna. What that did was it basically forced a lot of the motivation was cost reduction, but it forced a lot of complexity into a very small part of the vehicle. And obviously that makes the complexity around upgrading that functionality now very hard, because you are sitting on a very limited footprint, space-wise, cost-wise. There is not much room for upgradability. What we are starting to see in discussion with some automakers is maybe a reversal towards a more traditional TCU architecture, where the modem functionality is actually managed as a module and managed independently of all of the other software functionality, application functionality for connectivity. And that allows the modem in some sense to have the ability to be upgraded, while the functionality that relies on the modem to really remain the same. I think to your point about managing frequency bands and antennas and how those things evolve, it's a highly complicated topic because there is no one So first of all, there is a crystal ball involved in terms of you have to predict, what 6G is going to look like. I don't think that is a feasible topic really for anybody to be able to go do. The second piece is how do you map frequency bands in terms of what they will look like in the future. But I think it is fair to say that the technology that exists today, 4G and 5G, these are going to be around for a really long time. Really, they will be fairly coincident with the life cycle of the vehicles they're trying to plan for. And if you design a hardware architecture where the modem functionality is truly modular, you then have the ability to be able to make sure that the obsolescence risk is reduced to the farthest extent. The situation that you're talking about today with 2G and 3G, it happens to be, and of course, these were the early adopters for connected cars, where there is always a risk when you're an early adopter, who are going through this transition where 2G, 3G networks have been discontinued in some parts of the world, and you then happen to have the situation where you are marooned if you didn't have the right architecture.
Yes, and I really look at these capabilities, and certainly the life cycle of 4G is longer than the life cycle of 3G, and the life cycle of 5G probably will be longer. But we still will certainly, by kind of time frame that many car companies are starting to think about, 26, 27, 28, they put in 5G with the hope, say, expectation or what have you, that a car built in 2028 will be updated 10 years later in 2038, and whether we will still have the capabilities for 5G around in that kind of time frame is not completely known. But Johannes, let me go to you, because obviously there's a lot of long-term discussion of software-defined radios. I'm not convinced that software-defined radios as such becomes a capability that makes sense in the still. But I really do wonder about the issue of the ability, as Nicole talked, for the ability to upgrade software in the modem, upgrade software and handling the antennas, to be able to give the lifetime, because we go back to the capabilities that we live with. It's at least 3 years in designing a vehicle. Many vehicles will be produced for 5 years, pretty much unchanged. We are talking about having them be updatable for 10 or more years after they're produced. That says that the people who will be working on designs in 2025 will, to get that 10-year life of the vehicle that they put out in 2028 to start manufacture to 5 years to 2033, they will have to get 2043, or 18 years worth of communications life. That's a big challenge. How is that going to be addressed?
Yeah, thanks, Russ. Of course, this is always a very important topic. Maybe let me start with some remark. If you are talking about 2G, 3G, and the discontinuation in some of the parts of the world, and of course we are talking about technologies which are 30 or 20 years old. So we still have vehicles which are leaving the production line today, which have 2G, 3G modules only, not the 4G. So that is of course something which need to be changed in terms of upgradability or updatability in the vehicle production as such, so that the vehicle which is produced today should have the standards which are foreseeable for the next upcoming 2 to 3 decades in the market. Secondly, of course, the whole thing needs to be updatable by software. That is for sure something also we are, as Deutsche Telekom, working intensively in various aspects, also providing the platforms for the car manufacturers to make this software update happen and to control the huge variety in the field. Of course, the complexity needs to be reduced as much as possible, as Nakul has explained, but we need to face also that the complexity is still there and is, of course, the larger the fleet will get, we need to face this complexity, and it needs to be managed in the back end in terms of software updates. Thirdly, from time to time, we need also to face the situation that we need to upgrade hardware in the vehicle and to design a vehicle in a way that certain pieces of the hardware, which has an age of hardware life cycle, which needs to be updated, this needs to be available as well. And finally, most of the car manufacturers are going more or less in the same direction like the telco industry is also going, with all this kind of software-defined, whether it's a software-defined radio, whether it's a software-defined functionality in the vehicle. The beauty of software is that you can update a lot, so you don't need to rely any longer that much on specific hardware generations. And that is also something we see from the network operator side, but also from the car manufacturer's perspective for the electronics infrastructure in the vehicle.
Yeah, Frank, for Chang'an and the Chinese market, what do you see on these kinds of issues? How do you get life cycles that go through design, model production, and then at least 10 years worth of update capability? Are you looking at software solutions? Is Chang'an thinking of things where you could make your hardware to be easily replaceable? That's been talked about by vehicle manufacturers for a very long time, but no vehicle manufacturer has done it yet. What are your thoughts on how things are going to evolve, not only Chang'an itself, but in the overall Chinese automotive market?
Okay, that's a very good question. Yeah, so in China, actually we're doing this since right now. Yeah, I just talked about the SDA, the architecture. We actually done the really renovation about the EE architecture for the vehicle, because if the vehicle EE architecture still follow the traditional silo separate multi-domains way, it's just not possible for us to can keep our platform for 10 years, right? Even there's no feasible or safe for us to upgrade our software through the OTA, because there are so many different kind of hardwares, ECUs, right? So the major things that we are doing here for our SDA project, we actually do the one major thing that move to the silo separate domain-based architecture to this central computing centric architecture. So another part actually move from the many embedded software development based on the ECU to more general the computing architecture. So the software can be built as the IT software has, right? So we need out talk about the operating system. That part we build up another layer, to really decode different chips, from the up the layer the applications. So this operation not only for the like kernel capabilities, We also come out with this middleware to do the the hardware separation, and also doing the operating system separation stuff, right? So that can keep our upper the application and the algorithms untouched when we move from the one chip vendor to another one, because it's just not possible we can always change our can afford to always change our software architecture, because that's just the nightmare for us. So for need of the right architecture, move to the new computing centric hardware the architecture can help us a lot, right? So that's the two big things we're doing right now for China's next generation platform.
Thank you. Vishnu, how do you see Stellantis for both the high-end vehicles but most important, the mass market vehicles, managing and handling this overall issue of how to get close to 20 years worth of updatability from when you start designing a new model?
20 years of updatability is definitely a stretch goal to start with. In fact, it's difficult to imagine and envision all the use cases that will be applied that far ahead. One thing that we are doing is on the premium vehicles, we are over designing the systems in specific areas so that we can bring in applications that we have not yet envisioned. On the cost sensitive vehicles, we are creating the pipe to access edge and cloud via 5G with high bandwidth and low latency, so that we can launch some of these applications and services through the cloud without having the dependency on the physically installed capabilities. From our point of view, there are different levels of enablements that can happen. Some have sensor dependencies, but there are some which will be in new ways. The vehicles will be used, the vehicles will be shared, and we are preparing a holistic cloud platform and third-party ecosystem so that we can bring our cars into that ecosystem where several players can bring solutions to. So from hardware enablement point of view, there are varying levels. At price sensitive markets, the hardware enablement is limited, whereas when we talk about premium brands, we are able to plonk in the hardware and then unlock the value later through the lifetime of the car. So this is a very interesting challenge that we confront on a daily basis.
So Vishnu, there's a social issue as these things evolve. As you know, the older vehicles tend to be owned by, say, the lower economic levels. In a lot of cases, from used vehicles are exported from developed countries like US or European areas to underdeveloped countries. We're looking at building these vehicles with the software capabilities. And as you mentioned, even electric vehicles maybe will have longer lifetimes. ICE vehicles just within the developed countries now, US, Europe, and others, tend to have lifetimes of at least on average 15 years. What is the vehicle manufacturers responsibilities in considering the basic issue of social responsibility towards these old vehicles, or even if we talk about 10 years of updating them, that's still relatively short for the lower economic levels of drivers, owners of older vehicles.
You're bringing a very interesting point, Russ. And it is the fact that the vehicles move to different geographies that we originally don't intend for. And also they go to different set of target audience who might not be used to consuming these services through subscriptions. So one thing that we are doing is we are building the base functionality in the product, which is independent of the cloud delivered solutions or the value additions that can be seen on top. So that base functionality is robust.
Okay.
The robust functionality is guaranteed to work in all locations and all geographies, even if the vehicles are moved. And we are bringing also simpler ways to activate these features. Even when you talk about the vehicles moving to developing countries or even underdeveloped countries, mobile apps, micropayments through mobile apps, these are pretty popular in these areas. So many of our feature activations, everything are based on these kind of easy entry points where they can also participate. So the base functionality is available, and we make the advanced functionalities accessible through simple activation methods.
Okay, thank you. We're getting close to time. Nicole, let me switch to another area of interest. Cybersecurity. We now have a UN regulation in cybersecurity, and it's a good start at things. However, we see major problems with hacking of very substantial corporations for just their regular business. How comfortable are you that there will be cybersecurity solutions from the vehicle manufacturers that really protect us from having these future software-based vehicles from being hacked, particularly as they move to automated driving, where hacking could deliberately cause accidents and be able to, by a nefarious party, to actually create havoc, possibly killing people?
And look, I think security is serious business, and it's not something that you can ever be satisfied with in terms of whether you've done enough or not. Like you said, I think the UNEC regulations are a step in the right direction. We are starting to see, security become a key facet of really every design, every subsystem, especially subsystems that are connected to the cloud, have an exceptionally higher level of security being designed into vehicles. But this is similar to the other topics that you talked about around making sure that the software in the car is current, it is valid, regardless of what the economic incentive is. I think security is right in the middle of that. And it's more than just autonomous driving. I think as cars become more software based, they really have to be treated by an automaker and the automaker suppliers as an asset, no different than an IT organization would treat an asset. There's a lot to go do, because really the car is, or the vehicle is really a platform like no other, where you are integrating functionality and capability from so many different entities in the supply chain, building a very strong underlying security architecture is step one. And like with any design, if you have the right design, I think it is scalable. You have to make sure that you get the design right. So this clearly is an area where the responsibility lies squarely at the automaker's feet, because ultimately the automaker is integrating the overall end-to-end vehicle architecture alongside all of the suppliers that the automaker is working with.
Yeah, Vishnu, what are your thoughts?
Yes, as Nakul pointed out, it's an ongoing problem, and I think mobile industry has embraced it, and mobile industry has gone into a rhythm of security updates, even closer to monthly basis. When we deploy the systems that we are building today with 5G, with huge pipe being exposed, and also the advanced compute and communication capabilities inside the vehicle, I wouldn't be surprised even if we as an industry move towards monthly security fixes and the enhancements to actually solve the continuously evolving problem. So this is not something that we can fix, we can implement today and call it done. So this is about bringing the cadence of updates.
Okay, Frank, what is Chang'an and the Chinese auto industry doing and looking at for the cybersecurity area?
Yeah, definitely it's one ongoing common issues, right? It's not only for the vehicle industry, but it's more crucial for the vehicle industry because we need a lot of safety related, problems potentially. So in our, the Chinese practice, we really, put the cybersecurity concern into our original design. So that's hugely important. It's not just adding up capabilities. The second thing is that, from the cybersecurity, just as the, function safety, we need to sense there's no perfect solutions, right? So, but we build our solution pretty structure-wise. We, build use some technology, do the network sites, the preventive, the network attacks, right? We also doing the data and the information level protection for the cybersecurity. And the third one, we also do a lot of application level, cybersecurity, prevention stuff. So that's the, since, still, involved, based on the, the scenarios. The third one, I think, there should be some standard-wise, for how to handle well with the, deal with the cybersecurity from the community, the level staff. And I also think that there should be some kind of regulation we need since, on the, cybersecurity stuff, need people realize the, the issues there.
Okay, thank you. I see from the time that we've run out of time. I want to personally really thank the panelists. I think this has been a very useful discussion. I hope everybody who's listening found that the time was worthwhile. For the closing remarks, I'd like to ask my friend Chae-Sup Lee to provide the overall summary. Chae-Sup is the director of the ITU Telecommunications Standardization Bureau. Please provide your wrap up of FNC 2022.
Yes, thank you very much, Rashid. My apologies because we are in the council meeting, so for me it's difficult to catch up what you discussed, but I got some of good feedback from our colleagues. So I want to say this, I'm very, very happy to continue this, our FNC event this year. So every year, this symposium welcomes a wealth of experts deeply invested in our discussions. We see that our participants always return, and this could be no better indication of the value of this event. So we approach our discussions from the perspectives, technology, business, and the policy aspect. And this holistic view is essential when considering this mobility. I thank you all very much for your enduring support. We have discussed the state of the art and the future of wireless communications in the automotive context, and the prospects for the innovation introduced by 5G will certainly remain a key feature of our discussions in years to come. So we have looked at the technology and the business dimensions of emerging automated vehicle use cases, from delivery drones to robotaxis, once again, highlighting the merits of automation and its importance to our future. So discussing the differences between simple AI and the strong AI, we supported policymakers and the standard developers in their work to express clear intentions when defining strategies or work programs for highly automated and driverless vehicles. And for solution developers, our discussions on AI highlighted the importance of identifying and stating explicitly the level of intelligence that they aim to achieve, especially when their goal is for a vehicle to be driven without human involvement. So this event has always been of great service to ITU in helping us to clarify where our expertise can best serve you. So in this year, I was glad to see our session led by government authorities and the infrastructure players identifying a range of key issues highly relevant to the work of ITU. Issues, for example, the importance of avoiding technology redundancy as new technologies are introduced, data sharing and the communications reliability, including cross-border traffic considerations, data ownership, the challenges of digitalizing road signage at the national level, as well as in the wider cross-border context, the particular needs of partially sighted or visually impaired users of automated vehicles, and the possible need for data communication with users at the point of use. So these are issues that we will pay close attention to in ITU studies. As a final word of thanks, I would like to highlight my gratitude to our co-organizers, UNEC, and our generous sponsor, Shanghai Automobile, and also our speakers and the participants, and our highly dedicated moderators, Rush Shields, you, and also Rose Ranktot, and Michael Senya, and Ian Yarnold. So for our excellent programs, and as well as the many years of support you have offered this event, it's really appreciated. I should not forget to thank technical colleagues to maintain all these sessions in good, including also Stefano from ITU side. Thank you very much. My apologies again. So I have to return to council, but my sincere thanks for all your contribution. Thank you.
Thank you. Thank you very much, Director of the ITU Standardization Sector, for having nicely summarized this year's symposium in your closing remarks, and also for hosting the symposium series since 2005. Ladies and gentlemen, the symposium has successfully concluded. I would like to join the director in thanking the program committee and all that joined to provide a very insightful symposium program. In particular, Many thanks to all panelists, keynote speakers, dignitaries, and moderators of this year's symposium, and certainly all the attendees that joined live and provided interesting comments and questions, as usual. I'm very grateful to my colleagues at the UNECE, Mr. Walter Nisler and Mr. Francois Guichard, for their collaboration in jointly organizing this symposium. Also, I wish to thank collectively all my colleagues in the ITU that supported the symposium organization, communication, marketing, and administrative issues. Finally, sincere thanks to our sponsor, Chang'an Automobile, for their generous help. I hope the symposium will find its natural home at the Geneva International Motor Show next year, and I hope to see all of you there. This is Stefano Polidori from the ITU. Thank you all for joining. Stay safe, and see you at the symposium on the Future Networked Car 2023.
Thank you, Stefano. And I would like to personally thank Frank Hahn, Vishu Sundaram, Johannes Springer, and Nicole DeGaulle for taking their time and putting in their effort to make this session for a very good session and discussion. So I agree with Stefano. We really hope we can get back to the Geneva Motor Show. Thank you, everybody.
Thank you.
Thank you.